Hi friends, welcome to GMK tutorials. In this video, we are going to see about the current mirror circuit used in case of the differential amplifier. Okay, at the same time, the differential amplifier can be designed with the help of a MOSFET. Okay, so in this case, first we have to observe the common mode configuration. Later we will go for the second case. Okay, so in case of the common mode configuration, so this is a basic representation of the differential amplifier in differential amplifier. Okay, so in case of the differential amplifier, we have two types of transistor. That is nothing but transistor 1, that is nothing but MOS transistor. M2 is the second MOS transistor, where RD1 and RD2 are the biasing resistance of the corresponding two transistor. Maybe RD1 is also called the drain resistance of the first transistor, and the second one is the drain transistor of the second transistor. So this can be treated as a V01 output 1. So this can be treated as a V02. Okay, this is the two values for representation. Okay, at the same time, where RT is generally called a tail transistor. Okay, tail resistance. The basic purpose of this tail resistance is nothing but which reduces the common mode gain. Okay, so in order to achieve the exact value of the RT, so we need to maintain a minimum value of common mode gain. So for that purpose, we are using a active device, so that can be designed with the help of a current mirror circuit. This is a current mirror circuit. Obviously, I think all of you having some basic idea about this one. Just you have to replace this RT value with current mirror circuit. You will get a constant current value. Therefore, it reduces the common mode gain. So that is the basic agenda for this one. Suppose if you want to write the explanation, you have to write the like M1 is the input, M1 is the transistor 1, M2 is the second transistor, RD1 is the drain of the resistance of the first transistor, RD2 is nothing but drain resistance of the second transistor. So here RD1 and RD2 are same, therefore M1 transistor and M2 transistors are the identical transistor. Okay, so this kind of explanation you have to give in the examination point of view. At the same time, IN1 is the input for the M1 transistor, IN2 is the input for the second transistor, where V01 is nothing but output of the one. So output one output, so V02 is the second output of the differential. So like this, you have to extend your description regarding the circuit also. So now I have to find out the VDD voltage. So VDD is nothing but voltage drop across VDD is nothing but total power supply VDD, voltage drop across this one under the corresponding VGS value. So that gives the overall value. Therefore, VDD is equal to I reference into R bias value plus VGS4. From this, we know that I reference value is also equal to that M4 transistor value. So therefore, I reference is equal to IDSO4. At the same time, this is value is it depends on the KW by L into W4 by L by 4 ratio. At the same time, VGS4 minus VTH whole square. This is already predefined formula for MOS transistor. I think all of you are having some basic idea, right? In case if you have any doubts, please go through the basic. That is very important, right? So in this case, ID3 is equal to, that is nothing but ID3 is nothing but the current passing through this circuit. Okay, ID3 is nothing but current passing through the M3 transistor. Therefore, that is equal to this current. Okay, therefore ID3 is equal to I reference into W by L ratio of the third transistor divided by W by L ratio of the fourth transistor. That means this ratio divided by this ratio into this is nothing but a non-ideal factor. So this non-ideal factor is obviously equal to 1 because of the VDS3 and VDS4 difference voltage is obviously approximately 1. Therefore, you can neglect that value. Therefore, you will get a value. Suppose if you are thinking IDS3 and IDS4 both are having a W by IL ratio, W by L ratios are same in case of two transistors. Obviously, IDS3 is also equal to same I reference value. So that means the third transistor drain current is equal to I reference current of the fourth transistor. So that is all about the current mirror circuit in case of the differential amplifier with the help of in case of the common mode configuration. Okay, so thank you guys, thank you for watching GMK tutorials.